Hi everybody, an Intro to Computer Art class. It's week 4 and now we're here to learn about fractals, and specifically we're going to get our feet wet with the free downloadable program Apophysis, and later we'll touch on Ultrafractal too as another fractal program, but first I want to get you started with Apophysis. And we don't have a lot of time to explore this in much depth, but here we go. Anyway, go to apophysis.org, download the program. This is for PC people now, so I understand Marissa has a Mac, and in cases of Mac, we're going to have to substitute alternate fractal programs for you. So anyway, let me, before I take you into the program, in this video I want to introduce you to what a fractal is. And let's talk about that for a second. And let me just show you this paper that comes along with the program in a PDF. I don't expect you to read and understand much of it, so I just want to take you through some of the most important points. We as artists don't really worry too much about the math behind what's going on here. But because this is a class in Intro to Computer Art, I kind of want you to get the big picture understanding idea of what's going on. And the important point is that a very let me see here, put up a picture and show you. We don't need to know the algebra here and start plotting the algebraic functions out, but know that in a very simplest of all algebraic functions from 9th grade, you remember plotting out on a piece of graph paper the shape of a simple function, say x equals y squared. If you were to draw on a piece of graph paper a vertical line and a horizontal line, and for every value of x you'd place a dot. For every answer to the equation you'd put a dot on the axis, x and y, and that would be in positive and negative numbers. X equals y squared, so if the value is 1, then y squared equals 1, because 1 times 1 is 1. If x equals 2, y squared would equal 4, because 2 times 2 is 4. And you could take these and find the areas on the graph paper and put a dot, and then once you connect up all the dots, you'd have a beautiful curving parabola. And as an artist, I'm more interested in the shape of that line as an expressive possibility. I'm not so much interested in the math of it, although I find a little bit of understanding makes me appreciate some possibilities even more. This type of program, the dream of this began in the 1980s with the growth of computing power, and things were converging. And this is a form of iterated function. It means iteration means a repeat over and over again. If there's one thing computers do really well is they can compute formula and do addition and subtraction and so on, multiplication, division. And they can do it at this point billions of times a second. And then they can take the value that they discover and plot it down as a point, and we can create millions and billions of points, all with the elegance of a simple math formula. And that's very exciting. It's exciting to mathematicians and scientists. It has a lot of application and visualization for artists, for scientists and mathematicians. It helps meteorologists visualize weather, and the list is long. These forms that are being developed through this simple function is more important to me as an artist, though. Let me explain what a fractal is briefly. A fractal means that you're taking a shape and breaking it down into 1/2 smaller units of the same shape and smaller units of the same shape by half. So this triangle, if we were to then go a generation after that and take half the length of a side and create a new triangle, take half the length of that side and create a new triangle, and so on into infinity. It helps us describe the visual world in a way that was previously unavailable to mathematicians. Again, we're not going to do any math in this class. I just wanted to show you that you've got access in Apophysis to an extremely powerful tool that can help create very, very beautiful, I'm trying to find here, images. Okay, for instance, here's a random creation using Apophysis that creates these beautiful, elegant calligraphic lines. Okay. Now, one of the things I teach in two-dimensional art class is various symmetrical systems. The very first one is to take this and mirror image it, and we have on the right side, upper right here, what's called bilateral symmetry. That's how you're created, for instance. Hopefully, if you're a healthy person, you have a right arm and a left arm, a right eye and a left eye, right leg, etc., left leg. All mammals happen to be bilaterally constructed. Plants, on the other hand, are radially symmetric. Flowers, where there's a central point and you have various radii off of that point, and the first one is a three-way or triangular radial symmetry. Okay, those are bilateral, meaning across a central line, and radial around a central point. If you had a five-way symmetry, that would be 5 petals on a flower, etc. Okay. Let's see if there's anything else here. And in Apophysis, you can draw lines. Sinusoidal means that various cells decrease proportionally. Spherical, you know what that is. And swirls, we can make. Here's a heart that's available also. It's kind of interesting. Hyperbaric curves, diamond shapes, spirals, my favorite. Julia refers to a Mandelbrot set, which is the visualization of a particular math formula. And here's how they're plotted out. Again, don't worry about this. All we're going to be basically doing, and I'll get rid of this window now for you, is playing in here is this large sandbox with a lot of toys. And what I want you to do is, sort of as a captain of a ship, your job is to find elegant designs and have fun and play with this and create multiples. And we're not really worrying about how the ship was built necessarily. I mean, we're not down in the engine room fixing it. We have the mechanics to do that. We're not the engineers designing the size of the piston in the engine. It's left to the engineers. We're just worried about steering this ship and having fun with it, and saving these images out to our portfolios then. So I think I'll cut the movie off here. It's 8 minutes into it, and then the next one we'll get into specifically how to work Apophysis. See you in the next movie.